Hi there. In this video, we will do the national income analysis by using the matrix inversion method. Before this, we did the market equilibrium analysis by using the matrix inversion method. So this is the other economic application. We assume that we have a national income model which is composed of three sectors, that is the consumer, investor, and the government sector. And the investment is autonomous, so is the government expenditure. And we have the value of C, that is the consumption, in terms of its function, which is based upon the income. Now we have these two equations, so we can rewrite them in a certain order, and then we can convert it into matrix form. So the first variable is y and the other is c. So we will put y in the beginning and then c, and we will let all the other values remain on the other side, because they are considered as constants in this current situation, because they are autonomous values. And then we have this equation. This is also rearranged, and plus by becomes minus by. C becomes as it is because it is not shifted, and a remains on the right hand side, so it also remains the same. Now we have this placement in which y is to be written first, its coefficient, which is 1, and then the other coefficient is of y again, but that's minus b, so it will come below it. Then coming back to the first equation, its coefficient in c is minus 1, the other coefficient of c is plus 1. And then we have those two variables y and c, which is now equal to the constant matrix, in which the constants of the first equation and constants of the second equation. Now we have A, and then we have B matrix, and this is X. We know that actually they are being multiplied, A and X, and their product is equal to B. So X will be equal to this, that is A inverse into B. For A inverse, we find out the adjoint of A, then we divide it with the determinant, and primarily we have to find the determinant to see if it is a non-singular matrix or not, and it is, because we found the A determinant and it is not equal to 0, and that is possible only if B is not equal to 1. And that is also true because when it comes to the value of B, it is a marginal propensity to consume, and in normal conditions it is less than 1 and greater than 0. So if it is less than 1, then definitely it's not equal to 1, which guarantees that 1 minus b is also not equal to 0, because it will be something like 1 minus 0.6, so that will be equal to 0.4, and that will not be equal to 0. Then we have adjoint of A. For that, we can exchange the members in the principal diagonal and change the signs of the members in the secondary diagonal, so we will get the adjoint. Now we use the formula of A inverse, putting the value of the adjoint of A and putting in the denominator the determinant of A. Now we have this A inverse, we place its value in this main formula to get the value of X. B is also there, we put the value of it. Now simply we can multiply these two matrices, and this is where the multiplication is done, and this will remain outside. And now we have, after a little bit of simplification, this expression. This is y asterisk and this is c asterisk. We have simplified it, and now we have the equilibrium value of national income and equilibrium value of consumption. So these are the two values that we found by using the matrix inversion method, which is equivalent to the algebraic method of solving the simultaneous equations, because we will get the same answer. However, this method is slightly different because it is the method of finding the solution of the system of equations by using the matrix inversion method. So this is how we find out the national income and consumption level at equilibrium by using the matrix approach. Thank you.